let's take a look at lesson 100 today. In lesson 100, we're going to be looking at a couple of things, some irrational numbers and some real numbers, and we're also going to do some estimates of some square roots. So let's start with irrational numbers. An irrational number is a number that cannot be expressed as a ratio of two integers. So when we see ratio of two integers, think fraction. So an irrational number cannot be expressed as a fraction. Also, its decimal expansion is non-ending and non-repeating. So there's a number that pops in my mind, of course, when I think of an irrational number, and that number is pi. Okay, so pi, we know, because we've talked a lot about pi. Pi we can write it as a decimal number. However, the decimal numbers are non-repeating and they never stop. Okay, so that would make pi an irrational number. And you might say, well, you could write pi as a fraction because we've used 22 over 7 for pi. Yes, we have. However, that is an estimate of what pi is. That's not actually what pi is. So we've used 22 over 7 as an estimate. So that doesn't make it rational. Okay, so it's still irrational because we don't have a repeating decimal, we don't have an ending or a terminal decimal, and we cannot express it as a ratio of two integers. So that's just what an irrational number is. Now, we also have what are called real numbers. Real numbers are all the numbers that can be represented by points on a number line. So, real numbers can be rational or irrational. You might say, well, what about pi? Could I put pi on a number line? Absolutely, I could. I could graph it between the 3 and the 4, much closer to the 3. Okay, so I can still graph it. It's still a real number. It's just not a rational number, which is why we call it an irrational number. Okay, let's talk about some square roots here real quick. Oops, wrong way. Okay, says recall that the square root of a perfect square is an integer. Okay, so what does that mean? Well, let's take the square root of 25. Okay, 25 is a perfect square. So when I find the square root of 25, I know that that answer is 5. 5 is an integer. So we know what our perfect squares are. If we took 1 times 1, it's 1. If I took 2 times 2, that's, oh my goodness, that's 4. 3 times 3 is 9. 4 times 4, 16. 5 times 5, 6 times 6, and so forth. Okay, those are all my perfect squares. So I know that if I take the square root of any of those, my answer is going to be an integer. The square root of a number that is between two perfect squares, however, is not an integer, but we can estimate the answer. So here's an example. The square root of 29 is what? Well, let's see. I have to figure out 29 is between which two perfect squares. So if I go back to the perfect squares that I just wrote out, I can see a 25 and I can see a 36. 29 is between those numbers. Well, what's the square root of 25? It's 5. What's the square root of 36? It's 6. So the square root of 29 is going to be between 5 and 6. So it says 29 is between which two perfect squares? We found that out. It was 25 and 36. So the square root of 29 is between which two integers? Well, let's find those square roots again. We said 5 and 6. Okay, between which two consecutive means in order, whole numbers is the square root of 200. Okay, so if I kept going on my perfect squares, okay, I know 10 times 10, 100. 11 times 11, 121. 12 times 12, 144. 13 times 13, 169. Okay, 14 times 14, 184, I believe, but let's check in case I don't remember. So let's go up here and do 14 times 14. No calculators. 4 times 4, 16. Carry my 1. 4 times 4 plus 1 is 5. Let's do 1 times 4. 1 times 1. Let's add those together. 196. Okay, I don't want to make a mistake, so I'm going to double check those. And it's a good thing I did, because 14 squared is 196. 15 times 15 is 225. Okay, 225 is larger than 200, so I can stop. So, between which two consecutive whole numbers is the square root of 20? I'm sorry, the square root of 200. So 200 is between these two numbers. So what was the square root of 196? Well, I had to figure that one out. It was 14. The square root of 225 is 15. So my answers are going to be 14 and 15. At the beginning of this lesson, we estimated the square root of 29 to be between 5 and 6. So let's refine our answer even more. So in other words, let's get a little bit more exact. Okay, so if I said, well, between 5 and 6, let's try 5.4. So 5.4 times 5.4 is 29.16. Well, that's bigger than 29. So let's go a little bit smaller. 5.3 times 5.3 is 28.09. 28.09 is a little bit too small. So what does that mean? I know that means my answer is between 5.3 and 5.4. So I could try 5.31, 5.32, 5.33, and keep squaring those numbers to try to get closer and closer to 29. I could also try to do this problem on my calculator, and I could take the square root of 29. And I might come up with an answer like 5.3851648. So that would be the display on my calculator. However, this is a rounded number. The square root of 29 cannot be expressed as a decimal that is non-repeating or a terminal decimal. The square root of 29 cannot be written accurately as a fraction. Therefore, the square root of 29 is not a rational number. It is an irrational number. So please keep in mind, real numbers include rational numbers and irrational numbers. So all of these that we're going to talk about down here, rational or irrational, these are all still real numbers, but we have to decipher, are they rational or irrational? So pi, is that rational? Can be written as a fraction, or irrational? Cannot. Pi cannot be written as a fraction, so it is irrational. And can you just put an I? No. You would write the word irrational. Okay, square root of 2. Okay, we've talked about that one. The square root of 2 cannot be written as a terminal decimal, and it cannot be written as a fraction, so the square root of 2 is irrational. Okay, how about 2.3? And I have a repetent on the 3. So that means 2.3333333. Can this be written as a fraction? Because we know it's not a terminating decimal. Can it be written as a ratio of two numbers or as a fraction? Well, I know if I just take the 0.333333 part, that's the same as 1/3. So this could be written as 2 1/3. Could I change that to an improper fraction? So 3 times 2 is 6 plus 1 is 7/3. Look at that. I have a fraction that equals 2.3 with a repetent. So that means that since I have a fraction that equals this, this is rational. Okay, how about this one? You might look at that negative sign, it might throw you off a little bit. You might say, well, I don't know if that's rational or irrational. It doesn't matter. Can it be written as a fraction? Yes, because it already is. It doesn't matter that it's negative. So this is also rational. All right, have fun with lesson 100.